Hello. My name's Adolfo. Today I'm going to be teaching you the quiz process for this charge quiz. So we're given a situation where we're given electrons, a certain amount of electrons, protons, and neutrons. Or like there's electrons and then there's a nucleus with protons and neutrons, my bad. They tell you the mass, dimensions of the capacitor, plate distance, and plate charge, as well as the permittivity of free space and the permeability of free space. So the first question asks, if the nucleus is allowed to accelerate from rest through the entire accelerator, what will its final velocity be in meters per second? So there are actually two ways to approach this problem. First, you could approach it through using energy, right? Where you're saying that the potential at the beginning of the system is equal to the kinetic at the end of the system. And here I have our little diagram. The capacitor is 3 meters long, has a charge of 0.0121 charge. It's 1.71 and it's 1.71 meters, like split apart. And here's our little nucleus, just to draw a diagram. So as we know, is that charge is equal to capacitance multiplied by the change in potential difference. However, if we were to summate all of these individual charges, we would actually end up getting to potential energy as we started with zero energy and we ended out with the potential. So we could just integrate it to add all these little sums together. So through integrating in terms of, in respect to voltage, we get U is equal to 1/2 C delta V squared. And through some variable manipulation where we isolated in terms of V, we're able to get that potential energy in the system is equal to 1/2 Q squared, or Q squared over C is equal to 1/2 mv squared. So our capacitance equation is capacitance is equal to our epsilon naught multiplied by the area over distance. So we have our permittivity constant here multiplied by the area, because we're given that the dimensions of one plate is 3, so 3 squared over 1.71. We get our capacitance is approximately 4.66 times 10 to the negative 11 units of capacitance. Next, we want to find the mass of the actual nucleus. So we have 23 protons multiplied by the mass of each proton. And then we just add on another 21 neutrons with the mass of neutrons to get us a mass of 7.3654 times 10 to the negative 26 kg. So substituting into the equation, the 1/2s cancel out, we multiply through, and we can find V squared there. However, what you have to take into consideration is that this takes a lot of time and a lot of deriving. And this is very, very inefficient, when another alternative that we could use is force. So we know that electric field, right, of a surface can be represented by Q over epsilon naught area. And and this is basically just a way to, we're just isolating electric field of an area from the flux equation. It's electric field multiplied by area is equal to Q over epsilon naught. And here we're just dividing both sides by the area. Now, in order to convert field into something more preferable, we want to multiply it by a source charge. No, by a system. Yeah. Multiply it by small q, right? Another charge. And we'll get force. Once we have force, we divide it by the mass of the thing, and we'll find acceleration. And through using some kinematics equations, that could also help us find the final velocity. So the source charge, the charge of the nucleus can be represented by 3.68506 times 10 to the negative 18th. We just derived this through taking the 23 protons and multiplying it by its charge of 1.6022 times 10 to the negative 19th. Let me write that down real quick, actually. So our Q is represented by 23 multiplied by, so 1.6 times 10 to the negative 19th. Sorry, that's a bit small. But once we have that, we just multiply everything out, still using the same still using some of the values that we found from earlier. We're using the epsilon constant. We're using, this should actually be a 9 because that's, sorry. Yeah, sorry, that should be a 9. We're using the initial charge of the plate, or the system charge, multiplied by the source charge of the actual nucleus, and that gives us a force of an electric force of 5.59 times 10 to the negative 10 newtons. We want to divide it by the mass, and we already found the mass earlier, and we end up getting that to be 7.6 times 10 to the 15th meters per second squared. Now, using our kinematics equation, we know that this didn't have an initial velocity, so we could just cancel that term out. We'll have velocity final squared is equal to 2a, this change in distance. So just substituting some values in and just squaring it, I skipped a couple steps. 2 multiplied our acceleration, which is 7.6 times 10 to the 15th meters per second squared, multiplied by 1.71 meters, and we got our final velocity is equal to 1.612 times 10 to the 8th meters per second. Now, next on to the second question. We were given a Gaussian surface is the shape of a square box with sides that are half the length of the side of a plate. The Gaussian surface is cut exactly in half by the positive plate, so that two sides of the Gaussian surface are parallel to the surface of the plate and 4 are perpendicular. What is the flux through this Gaussian surface? So here we have what you call it, we have our box, right? Our Gaussian surface, and it's being cut in half by the plate. So as you can see here, the dimensions of the plate would actually be 1.5 and 1.5. And just to show how this would actually occur is that a charge would move through the plate, through the Gaussian surface, and what we're trying to do is we're trying to find the flux of this resultant. So we know the Gaussian surface, it will have a surface of 1.5 meters, like that'll be part of its dimensions. And then here's another equation that we have to use in order to actually like work this out. We want to find the charge per unit area, or this is an equation, charge per unit area multiplied by area would give you charge. Inversely, charge per unit area is equal to charge over area. So we're looking at the initial plate here first, right? So that's where we're getting these numbers from. Q is the charge of the plate, which is 0.0121 charge over 3 squared, which would be the area, and we get 1.34 times 10 to the third C. Then in order to actually find the charge of the charge that goes through the Gaussian surface, we have charge is equal to charge per unit area multiplied by the area, which would be 1.34 times 10 to the negative 5 multiplied by the dimensions of the smaller Gaussian surface, which is 1.5 squared, and that gives you 3.025 times 10 to the negative 23rd C. And then we just substitute this into our final flux equations, which is charge over epsilon naught. So we use the charge from the previous things multiplied by epsilon naught, and that gives us our final flux of 3.41653377 Newton meters squared over charge.